how does my computer store so many pictures, videos, and text into my device? How are these chips designed to store millions of bytes of data? What's the mystery behind hard drives and memory cards storing data? Hello there, my name is Tuhin aka Tuhin, and in today's video we'll be learning how exactly these semiconductors that are used in the computer chips store your data. Coming right up. To start with, what actually memory is? Well, you see, memory can be defined by its purpose. The basic purpose of memory, human or machine, is to keep a record of information for a period of time. One obvious difference between them is that human memory is extremely good at forgetting, which might seem like a major defect to you, but trust me when I say it's really clever tactic that humans have evolved. It helps us to focus on things that are immediately relevant in the endless clutter of our everyday lives. Computers don't remember or forget things the way human brains do. Computers work in binary, they either know something or they don't. Like us, computers also have a short-term memory for immediate tasks and a long-term memory for prolonged data storage. Computer memory is of two basic types: primary memory, or the internal memory, and secondary, auxiliary, or external memory. Talking about internal memory first, the chips that make up the computer's internal memory comes in two broad flavors known as the RAM, random access memory, and ROM, read-only memory. RAM chips remember things only while a computer is powered on, so they are used for storing whatever a computer is working on in a very short time. ROM chips, on the other hand, remember things whether or not the power is on. They are pre-programmed with information in the factory and used to store things like computers' BIOS. RAM and ROM are not the most helpful names in the world, as we'll shortly find out, so don't worry if they sound baffling. Just remember this key point. The main memory inside a computer is based on two kinds of chips: a temporary or a volatile kind that remembers only when the power is on, that is RAM, and permanent one, a non-volatile kind that remembers irrespective of whether or not the power is on or off, that is ROM. RAM comes in two main varieties called DRAM, aka dynamic RAM, and SRAM, aka static RAM. Dynamic RAM is more dense, that is, it stores more information in less space, because it uses just one capacitor and one transistor to store each bit or binary digit of information, 0 when no charge and 1 when charged, whereas in static RAM several transistors are connected together. DRAM is the less expensive of the two and has a higher density, that is, packs more data into smaller space than SRAM, so it is used for most of the internal memory you'll find in PCs, games, consoles, and so on. SRAM is faster and uses less power than DRAM, and given its greater cost and lower density, it is more likely to be used in smaller temporary working machines that form part of computers' internal or external memories. It is also widely used in portable gadgets such as cell phones, where minimizing power consumption and maximizing battery life is extremely important. The basic difference between DRAM and SRAM arises from the way they are built or basic electronic components. Both types of RAMs are volatile, but DRAM is also dynamic, that is, it needs power to be zapped through it occasionally to keep the memory fresh, whereas SRAM is static, it does not need refreshing in the same way. Like RAM, ROM also comes in different varieties, and just to confuse matter, not all of it is strictly read-only, as in read-only memory. The flash memory you find in USB memory sticks and digital camera memory cards is actually a kind of ROM that retains information almost indefinitely, even when the power is off, much like conventional ROM, but can still be reprogrammed relatively easier whenever necessary, more like conventional RAM. Technically speaking, flash memory is a type of EEPROM, aka electrically erasable programmable ROM, which means Information can be stored or wiped out relatively easier just by passing an electric current through the memory. You might be thinking, doesn't all memory work that way? By passing electricity through it? Yes, but the name is really a historic reference to the fact that erasable and reprogrammable RAM used to work in a different way. Back in the 1970s, the most common form of erasable and rewritable RAM was EPROM, aka Erasable Programmable RAM. EPROM chips had to be erased by a relatively laborious and inconvenient method of first removing them from the circuit and then blasting them with powerful ultraviolet light. Imagine if you had to go through that long-winded process every time you wanted to store a new set of photos on a digital camera memory card. The most popular kinds of auxiliary memory used in the modern PCs are hard drives, CD, DVD, and solid-state drives or SSDs, which are similar to hard drives, only they store information on large amounts of flash memory instead of spinning magnetic disks. But in the long and fascinating history of computing, people have used all kinds of other memories, most of which stored information by magnetizing things. Floppy drives, popular from the late 1970s to mid-1990s, store information on floppy disks. These were small, thin circles of plastic coated with magnetic material spinning inside durable plastic cases, which were gradually reduced in size from about 8 inches through 5.25 inches down to the final popular size of about 3.5 inches. Zip drives were similar but stored much more information in highly compressed form inside chunky cartridges. In the 1970s and 1980s, microcomputers, the forerunners of today's PCs, often stored information using cassette tapes, exactly like the ones people used back then for playing music. You might be surprised to hear that big computer departments still widely use tapes for backing up data today, largely because this method is so simple and inexpensive. It does not matter that tapes work slowly and sequentially when you are using them for backups, because generally you want to copy and restore your data in a very systematic way, and time isn't necessarily that critical. Photos, videos, text files, or sounds. Computers store and process all kinds of information in forms of numbers or digits. That's why they're sometimes called as digital computers. Humans like to work with numbers in the decimal system, base 10, with 10 different digits ranging from 0 to 9. All numbers can be made from these 10 digits. Computers, on the other hand, work using an entirely different number system called binary, based on just two numbers, 0 and 1. In decimal system, the columns of numbers corresponds to ones, tens, hundreds, thousands, and so on as you step to the left. In the binary, the same columns represent powers of 2, 4, 8, 16, 32, and so on. So the decimal number 55 becomes 110111 in binary, which is 32 plus 16 plus 4 plus 2 plus 1. You need a lot more binary digits, also called bits, to store a number. With 8 bits, also known as a byte, you can store any decimal number ranging from 0 to 255. This to this in binary. I rather prefer not to say this number in words. One possible reason why people like decimal numbers is because we have 10 fingers, and I can't believe I'm saying this, but computers don't have 10 fingers, right?
Or does it?
What they have instead is thousands and millions or even billions of electronic switches called transistors. Transistors store binary numbers when electric currents pass through them by switching on or off. Switching on a transistor stores a 1 and switching it off stores a 0. A computer can store decimal numbers in its memory by switching off a whole series of transistors in a binary pattern. I personally have a bunch of floppy disks that my grandfather used to use back in the 80s. What old piece of technology do you have? Tell us in the comments down below. Hope you like this one. What other topics do you want me to make video in? Do mention in the comments. I would love to take your suggestions. And see you in the next one. Until then, keep it real.